In this video, I'll show you how to calculate a binomial distribution using the TI-84 calculator. The keystrokes are second and then vars, then choose binomial PDF from the list. Binomial PDF has three parameters. N is the number of trials, P is the probability of a success, and X is the number of successes. For example, if you're given that 60% of all women are employed, if 20 women are chosen from this study, you're asked to find the probability that exactly 15 of them are indeed employed. This would be written up as P of 15, where 15 is the X. N would be 20. And P is obtained from the 60%. You would write it as a decimal. P is equal to 0.60, and I'll write that in a streamlined way. I can write it as 0.6. The work you would show is that you would write the function binomial PDF, open a parenthesis. I'll make the n comma p comma x specific to the example. It would be 20 comma 0.6 comma 15 close parenthesis. Then in the calculator, I'll follow the instructions. Second, vars, use the down arrow to get to choice A, binomial PDF, not to be confused with binomial CDF, and see how this is already keyed in. Number of trials, that's N, is 20. P is 0.6. The X value is 15. Then you just use the down arrow key one more time to highlight paste and hit enter. That'll bring you back to the main screen. Now it says binomial PDF, parenthesis 20, comma 0.6, comma 15. To do the actual calculation, you would just hit enter. As a decimal, this is 0.0746. And if I'm rounding to the nearest thousandth, the 4 is in the thousandths place. Because there's a 6 in the next place, you'll round up. Therefore, rounded, this would be approximately 0.075. Next, in the same scenario, if you're asked to find the probability that at least 18 are employed, then that scenario would be the probability of 18 being employed plus the probability that exactly 19 are employed plus the probability that 20 are employed. To use binomial PDF, you actually don't even have to go back to the menu. You can just reuse what you already have. You do second, enter, then use the left arrow to go over to the 15, change it to 18, and then hit enter. The probability of exactly 18 in this scenario would be 0.003087. And I'll write down more than to the thousandths place. Better to take more and round later. Then for probability of exactly 19, again I'll do second, enter, change the 18 to 19, enter. And this is a very small number. This is in scientific notation. The way to convert this out of scientific notation is to move the decimal point 4 places in the negative direction. 4.87 times 10 to the negative 4 would be 1, 2, 3, 4 plus 0.000487 plus second, enter. I'll change 19 to 20. For this answer, I'll move the decimal point over 5 places, which means I have to fill 4 decimal places with 0, then 3, 6, 5, 6. Adding these together, 0.003087 plus 0.000487 plus 0.00003656. I'm just repeating the line that I have here. Enter. This works out to be 0.00361056. It's always a good idea to write your unrounded number, then rounded to the nearest thousandth. This would round up to 0.004. I hope you found this helpful. Thanks for watching.